I can and am recording. All right, good evening, everybody. We are live and recording here for July 16th, ProfessionalVMware.com's vBrownbag. I'm Anthony Hook, and I'll be the host for the evening. Tonight we have Tom Hollingsworth talking about the Cisco CCNP DC certification, Part 2. Tom, thanks for coming on with us tonight. What do you have in store for us?
Thanks, Anthony, for having me back. I guess I didn't scare off too many of your listeners. Tonight we're going to be talking a little bit about the CCNP data center. We're going to cover the Fabric exams.
All right. Just a few more things to talk about before we get started. Talking about the Fabric exams. We're running a summer book giveaway, which is running through Friday, August 1st. Visit ProfessionalVMware.com for a chance to win one of several books, including DevOps for VMware Admins, Essential Virtual SAN, vSAN, and vSphere Design Best Practice, brought to you by VMware Press and Pact Publishing. I get that one wrong all the time. You can also join us in the conversation on Twitter. Use the hashtag vBrownbag, and you can ask your questions in our GoToMeeting window as well. This episode and all other recordings are found on ProfessionalVMware.com, YouTube, and the iTunes channel is a bit behind, but we're working on that, so we'll get that up to date. You can also hit bit.ly.com/vBrownbag iTunes for the generic RSS feed and throw that in your favorite reader or podcast app. We have other shows around the world too. EMEA vBrownbag, which runs every Tuesday at 2 Eastern for those in the U.S. APAC every other Thursday, and the LATAM show every Thursday as well. With that, Tom, I'm going to turn this over to you and change you to be the presenter, and we'll get started.
Thank you, Anthony. I appreciate it. All right. Well, thank you very much for coming back to vBrownbag. I decided to help out again. Dan Barber, who did last week's CCNP Data Center Part 1, I did a great job on it. He asked me to give him a hand with Part 2 this week, and so I was more than gracious to give him a hand. We're going to be talking a little bit about the Fabric exams that go with the CCNP Data Center. We'll cover a little bit of the technology that's on there, as well as some tips and tricks for how to pass those exams. So for those of you who may not know who I am, my name is Tom Hollingsworth. I am a CCIE. I've been one for about 3 years. I am a speaker and industry analyst type person, but I also write a technical blog at networkingnerd.net. You can also follow me on Twitter. My Twitter handle is networkingnerd. Warning, it does get a little snarky from time to time. And I have been a CCNP since 2007. How long ago was that? Well, I actually know what the aux port on a router is for when they had aux ports, because I had to take the remote access networks tests. Let me tell you, those were a lot of fun. But the CCNP has changed a lot since I took it. There are now specializations: CCNP Voice, CCNP Security, CCNP Wireless, and Data Center. And that's why you guys all came to this program, is to learn how the CCNP Data Center works. So without further ado, let's get going. So the CCNP Data Center is an exam that requires you to pass 4 tests. But unique to Cisco, you can actually mix and match those tests from a specific group. Now, with regards to the Fabric tests, which are the tests that cover everything that isn't a server, 642-997 is required. You have to take that test. That's implementing Cisco Fabric. Once you pass that, you have an option. You can either take 642-996, which is the Cisco Designing Fabric exam, or 642-980, which is the Troubleshooting Cisco Fabric exam. You can pick either or. So what that means total is you have to take 4 different exams. There are 6 available. You can mix and match the 4 of those 6, provided you take the 2 required, which are both of the implementation exams. Be sure to go to cisco.com/go/study to read through everything, including a list of the blueprints and a bunch of other stuff. And if you're not already at the Learning at Cisco site, I highly recommend it. They have really great resources there, including forums where you can discuss a lot of the questions that we might bring up here on the vBrownbag, and they have a really great community there as well. So what is Fabric? It's not the stuff we make blankets out of, although I do have a cloud blanket that I throw over my head anytime anybody starts talking to me about cloud, and it's really soft fabric. In this case, Fabric is everything that connects things together in the data center. So it used to just be that was an easy answer. Oh, it's the network. Well, it's a little more than that now. There's more things. Things like Fibre Channel over Ethernet make the terminology of network a little more nebulous, a little cloudier, if you will. So keep in mind that when we talk about Fabric, it's the interconnection of servers, it's the interconnection of storage units, and some other things. Those things are all going to be tested on the exam. You're going to see questions over specific networking protocols. You're going to see questions over specific storage protocols. Be aware of what they are. We'll cover some of them tonight. And obviously, if you guys have any questions about anything, feel free to hop in and shout them out. But the important things to know: sets of exams. Know what the Fabric protocols are. Kind of understand what they're about, what problem they solve. That will get you through the implementation exam. Know when you're supposed to use them, and we'll cover that a little bit with design exam. Design exams are all about why do you choose to use this protocol over that protocol? Why do you use FabricPath here instead of OTV? So if you know that and you know the business case for each of those, you're going to do fine on the exam. And then what happens? How do you prove that what you just configured is actually working? That's the heart of the troubleshooting exam. And I'll tell you guys something right now. If you're going to go up the ladder from CCNP to CCIE, you need to burn the troubleshooting commands into your brain, because the fastest way to fail the CCIE exam is to not figure out how to show what you just configured. So understand the troubleshooting part of it. All right. Well, strap in, guys, because we are going to jump headlong into this with OTV. OTV is Overlay Transport Virtualization. It's a Cisco construct that they came up with to allow for long-scale data center interconnects. So if you guys are VMware people, and if you're listening to this podcast, you likely are, you know that in order for things like vMotion to work correctly, your data center has to be layer 2. Keep in mind that when these exams were written, NSX didn't exist, and the concept of a layer 3 vMotion was a fantasy. In order for the VM to be able to swing its I/O without impact, it has to basically rewrite the MAC address for the IP that you're talking to. So everything has to be layer 2, which is great if you have one geographically located data center in Los Angeles. But what happens if you have another site somewhere in, say, New York or Atlanta or Virginia, and you need to move everything over there because there's an earthquake or a fire or something like that? Well, how do you get those two things to link up at layer 2? Because there are some issues there. If layer 2 domains get too large, they start sounding like a cocktail party. It's impossible to actually hear real conversation for all the noise. So Cisco came up with the idea of OTV. And what OTV does, if you look down here in this little diagram, is it allows you to mark edge devices and say, these guys are going to be essentially gateways into an OTV network, and OTV is going to extend the layer 2 connection to a different data center across a link. Now, if you look at OTV with your hands over your eyes, you're going to say, oh, I've seen this before. Yes, you have. OTV looks a lot like MPLS, but it's MPLS in easy mode. And I didn't realize exactly how easy mode it was until I started doing a little digging for this recording, and I found a lot of great resources from people like Denise Fishburne, Tony Burke, who runs a blog called Data Center Overlords. When you configure OTV, it more or less just works. And we'll cover that in just a second. You plug it into the WAN side, and you configure some VLANs, and you turn on multicast, and everything just kind of works. and it does its job. Now, most people who do this do it in a lab, and when you've only got 2 endpoints in a lab, it's actually kind of easy to make it work with some caveats. It's when the things go wrong that you kind of have to understand what goes on with them. So let's look at OTV. Here are some things you need to know about how to use OTV. So the first thing you have to do is you have to designate a site VLAN for each site that's going to participate in OTV. And basically that's like an area code. If you configure it so that the edge OTV devices can find each other and understand that they're part of this site. Do not let that site VLAN be populated across OTV at all. Block it at the edge. You actually have to go in and manually extend the VLANs that are going to be used over OTV. If the site VLAN shows up in 2 different sites, OTV will break. So be sure that you fix that. Also, make sure your site IDs are unique. I know it sounds like a no-brainer, but when you get into the lab and you start plugging away at this and you're like, oh, I'm going to call this one Site 1, this one Site 2. Well, do I have a Site 1? I'll make that one Site 1. Things are just going to go wrong. Know how multicast works and make sure yours is working, because multicast is what's used in the cloud portion of OTV in order to populate information back and forth across the sites. And if your multicast doesn't work, your OTV is not going to work. It's better than it was in the initial spec. I remember looking at it going, well, this is cute. You're basically using dense mode multicast. It's better now. They're using source-specific multicast, which allows you to cut down on the amount of traffic that's being flooded. As I mentioned before, the data center interconnect VLANs, they have to be extended through OTV. Again, sounds like a no-brainer, but it's usually like the last step that you leave out. If you do not extend the site VLAN across the OTV link, you won't have a VLAN on the other side. And, well, then you're going to have problems. One other thing you need to be aware of, know how your first hop redundancy protocols are going to interact with OTV. And I'll give you a little hint. It's probably not the way you were thinking of it. So for those of you who are not familiar with first hop redundancy protocols, these are things like hot standby router protocol, HSRP, VRRP, which is the industry standard HSRP, and then there's one we'll talk about in a little bit, GLBP, Gateway Load Balancing Protocol. You want to make sure you know exactly how those are going to interact with OTV, because if you run into a situation where the gateway that you choose for your traffic to exit the data center is populated on the other side of an OTV link from a site, you're going to be tromboning that traffic from your server through the OTV link, out the gateway, back across the OTV link, and out your local internet connection. You do not want to do that. So make sure you plan this all out in advance. OTV needs to be drawn out with crayons on a cocktail napkin before you ever actually try to do it in real life. OTV, like I said, is very, very simple. Make sure you read up on it. There's a really great post out there, and I'll probably link this in the show notes, from Denise Fishburne, who is a really great Cisco person who basically went into the lab and broke OTV on purpose to figure out what needs to be fixed when OTV breaks. And if you're going to try the troubleshooting exam, break OTV before you actually try to make it work. I'll tell you that I've learned more things from broken Linux boxes than I ever did from man commands, because when it breaks and I have to make it work again, that's when my real learning starts. And that's how you should approach this if you're going to take the troubleshooting exam, is configure it and then start screwing things up. In a lab, of course. Don't do this in production. So are there any questions about OTV?
Yeah, Tom, I got a couple questions for you. One of them is, how does the OTV, how does it actually compare to EVPN? They sound sort of similar. How do they, what's the difference?
I am going to punt here because I'm not 100% sure what an EVPN is. I'm sorry. I'm going to have to admit that. Here's what I'll tell you. OTV was initially conceived of about 3 years ago. It's very, very similar to like a VXLAN connection and some things like that. It's basically a tunnel. It's a layer 2 tunnel to another data center. Let me do some looking up EVPN stuff. I honestly would not be surprised to see EVPN have a lot of similarity with OTV. The other thing you have to take into account if you're studying for this exam is that the exam material was written about 2 years ago. So, we'll get into it a little bit. There's going to be a topic about Cisco Virtual SANs, VSANs. That's a virtual storage area network construct. It is not a thing from VMware that allows you to build commodity SANs. So I hate to say it, but these exams really are an artifact of their time. So you have to kind of keep that in mind when you're taking them. But I'll do some reading on EVPN, and I may even write a blog post about EVPN and OTV. So that is actually a really good question, and I will find an answer for you.
Sounds good. One of the other questions that came through is, well, somebody noted that OTV can be used in unicast mode if multicast mode is, or if multicast is unavailable in your transport.
Yes, it can now. Initially, it couldn't, but Cisco did some work on trying to make unicast mode work correctly. And you are right. You can unicast OTV because so many people complained otherwise. Because running multicast in the core of your network is not something you typically do, because you have to set rendezvous points and other things, and they all have to be right. And if you ask any CCIE candidate, if you say anything about multicast or RPF checks, you'll see that shiver run right up the back of their spine, because multicast will kill you if you're not careful. So let's talk a little bit about FabricPath. If you watched my CCNP data center section, I talked a little bit about FabricPath, but FabricPath is a bigger component in the CCNP exam, so we're going to talk a little bit more about it. So what is FabricPath? FabricPath is Cisco's attempt to get rid of spanning tree. For those of you who are not networking people, spanning tree is this beautiful thing that Radia Perlman created at Digital Equipment to prevent layer 2 network segments from looping together, and it works really well to do that. The problem is it was never designed to be implemented in networks where you have things like multipath or multiple connections to things. Because the way it works is it shuts off one of your links. Well, that's great if you want to make sure you don't have a loop. But if I have two 10 gig links coming out of a server, or if I have two 40 gig uplinks to the rest of my network, I would rather not have one of those blocked. And so Cisco said, well, we need to find a way to prevent that from happening. So they came up with FabricPath. And if you're not familiar with FabricPath, it is Cisco's implementation of something called TRIL. TRIL stands for Transparent Interconnection of Lots of Links. It is Radia Perlman's new version of spanning tree. And in a nutshell, what TRIL and FabricPath attempt to do is they use ISIS, which is a service provider style routing protocol that does not need IP. It can actually run at layer 2, and it builds paths between your network. And it allows you to prevent loops by essentially creating a link state database for layer 2. Hooray! And it works really well. Now, it does require you to have the enhanced layer 2 license on your Nexus gear. So keep in mind whenever you are building this out. Again, I wanted to make sure you knew that it does require the enhanced layer 2 license. Why? Because that may be important later. Licensing questions are always really popular on these exams, especially if you're going to take the design or the troubleshooting exam, because they'll tell you, well, here's this thing and it's broken, and here's the show command output from the switch. Why is it broken? And you look down and you go, oh, that's because you're using the standard license, and that feature is an enhanced license feature. It tests your knowledge of the feature, and it tests your ability to read a config output and go, that's not right. So burn that into your brain, because you might see that later. Now, how does FabricPath work to things that are not FabricPath enabled? Because the other thing is FabricPath does not do traditional forwarding the way you and I think about it. So if you try to plug something non-FabricPath into FabricPath, the way that it works is everything that's connected to the FabricPath looks like one gigantic bridge, a spanning tree device. So let's say you have Nexus 7Ks running into Nexus 5Ks, the 5Ks run into 2Ks, and there's something like 15 switches to a little 3850 running over in the, like maybe your firewall, like that, layer 2 connection, back to one of those Nexus 2Ks or even the Nexus 5K. All of those 15 switches look like one switch, or one bridge, technically. So FabricPath sorts itself out, and when it needs to go anywhere off the FabricPath, it manages to do that. It's also a little bit of black magic. When you turn FabricPath on, things just work. But please do not forget to configure the switch ID for FabricPath, because if you don't do that, it's going to break. There are really good how-tos out there about doing FabricPath. I suggest you pull one down and read through it so you understand what's involved in it. I know that there were some FabricPath questions last week, or I'm sorry, my last presentation. It's a really good protocol, especially if you use nothing but Cisco in your data center. You're going to run into problems, though, if you are running something else, like if you have Brocade switching or something like that, because Brocade uses something similar to this. DCS, it's Brocade Trill. FabricPath is Cisco Trill. Everybody has their own flavor. So, you know, caveat implementor on that. And if there are any questions about FabricPath, we'll jump into those. Let's talk a little bit about virtual port channel as well.
There is a question quick on licensing for OTV. Sorry about that. You said there were some licensing questions on the exam. Is it standard on the 5000s? Do you know?
I'm not sure.
Okay.
I don't know if it's standard on the 5000s. I think it would require an enhanced service license. So, in a nutshell, Cisco basically has two kinds of licenses that go on switches. There's the standard image, the base image, and then there's the enhanced image. The standard image gets you all the layer 2 stuff. The enhanced image gets you everything you want and is also twice as expensive. So for switching, like layer 2 switching is on the standard base image. Layer 3 switching doesn't come in until you get the enhanced stuff. And yeah, I know you can technically route between VLANs on a layer 2 switch, but you don't want to do that. I would guess OTV is an enhanced feature on the 5K, but I will confirm that for you before I just shoot my mouth off. And licensing questions change with every revision of code, so be sure you go out and you know them before you go sit the exam. And also remember that something that just recently became available in a lower end card may not necessarily have filtered into the test yet. So when you read the question, kind of look at it and say, well, when they wrote this exam question, did OTV was it included on the base license or was it enhanced? I would guess it's going to be an enhanced license. So FabricPath is great for doing elimination of spanning tree. But one of the other things that Cisco came up with to prevent this is something called virtual port channel, VPC. If you've ever worked with a Nexus switch, you have seen VPC a lot. So what happens when you create VPC? So if you see right here in this diagram, this connection right here between these two Nexus 7Ks is a VPC link. And when you see a circle around two wires coming between two switches, that's a bundle. That's telling you that that is one bundled or one aggregated link, Ether channel, LACP, whatever you want to call it. What happens with VPC is it allows you to create a link between those two switches, so you don't have to run spanning tree and block these links here. It allows these links to be active-active instead of active-passive with spanning tree. So, for instance, this link would be forwarding to this switch, and this link would be blocked until this link dies, and then this link forwards to that switch, and then comes back through here. That's not the case. Physically, we connect them like this, but if you look at it logically, this guy is this box, and these two guys have aggregated links that go up here. And it's really, really good to get rid of spanning tree. Most implementations that I've seen of Nexus 7Ks in the core recommend you use port channels between the two of them, VPC, to connect them together. Now, one of the things that you need to know about that is that if you're going to have dual home hosts with FabricPath, you have to be running VPC between your Nexus 7Ks. It's just a requirement. And VPC does use Trill a little bit. I was able to dig that up to send the packets where they're supposed to go. And once again, requires the enhanced layer 2 license. Everything is going to require the enhanced layer 2 license, kids. I would read up on VPC a lot because there's going to be a lot of questions over it. It's one of those flagship, we came up with this really awesome thing, and you need to read about it. The other thing I highly recommend is there's a Cisco NXOS Bible out there by Ron Fuller, CCIE 5851 on Twitter. Get it and read it before you take any of these exams, because you will know more about the Nexus gear than the people who built this thing from Ron's books. Ron writes really, really good stuff. It's thick. Don't get me wrong. This is not one of those books that you're going to plow through in a weekend. In fact, you're probably going to read it, and then you're going to put a sticker on it for the stuff you're going to use all the time, and then you're going to keep going back to it until the cover falls off and the pages are all yellow and a couple of them are bent and there's a coffee stain on it. But that's a good book that you want. Now, you might see some references on the exam to VSS, which is the virtual switching supervisor engine that Cisco uses in this Nexus or the Catalyst 6500 lines to do something similar to VPC. There is one major difference between VPC and VSS that I'll tell you about. VPC allows the control planes of both switches to be independent of each other. So the supervisors on both Nexus 7Ks are in active mode and running at the same time. With VSS, even though they're logically one switch, one control plane takes over. So there can be some issues with failover if you don't build it right. Whereas with VPC, if one of the control planes fails for some reason, the other one will just pick up and keep working. So, but VPC is Nexus only. You cannot run VPC on Cat 6500s or any other non-Nexus gear. So if you're running Nexus, you need to be running VPC. While we're talking about the Nexus, let's talk a little bit about the line cards. So with the line cards, there are two different models that you're going to hear about, the M series line cards and the F series line cards. The M series line cards, the M basically stands for multifunction, and the multiple functions that you're going to get out of it are layer 3. So if any of you out there ever worked in networking gear in the past on 6500s, and let's face it, 6500s have been around longer than, well, some companies that are selling networking gear. They used to have a thing where they had to have a layer 3 routing engine on one of the cards in order for packets to make layer 3 forwarding decisions. Otherwise, it was just a really, really big layer 2 switch. Well, on a Nexus, the same thing happens. An M-series line card is your layer 3 routing. So make sure you have an M-series card on there if you want to do layer 3 with it. Now, that's not the case on the Nexus 5000 because the 5000s have layer 3 built into the code, because it's a slightly different model of switch than the 7K. Now, the F-series line cards, those are fabric line cards. So they have things like FCOE connectors on them, which you're going to want to use if you're using Fibre Channel over Ethernet. And the first generation, the F1 series, only did layer 2. So you had to have an M-series card in there to be able to punt packets to layer 3. Now, they have come out with new line cards recently. The F2 line cards can do very basic layer 3, so they can run a routing protocol and they can interact with things. But two things they can't do is run OTV and MPLS, because the CPUs on the F2s are still not beefy enough to do some of those complex calculations. They're basically engineered to do Fibre Channel stuff. So keep that in mind if you see questions about capabilities of M-series and F-series. M-series are designed to do lots of things, but they're layer 3, and F-series are interconnects at layer 2 for FCOE, and if you see any reference to the F2, it can do a little bit of layer 3. And fun fact, if you are a fan of the Nexus series, you should read my friend Jeff Fry's blog at fryguy.net. He actually has found some of these line cards before they've been publicly announced, because he likes to go through the MIB files that are the descriptor files for all of the SNMP stuff, and he finds references to strange cards that have racing names. So if you're a trivia nut like I am, almost all of the line cards in the Nexus gear are named after racetracks. And if you crack the case on one and you slide the line card out and you look all over the board, you'll actually see that certain line card series The emblem on the main board is a stylized version of the racetrack that they're named after. Jeff actually has a couple of shots of those cards on the boards, and it's actually no coincidence that Ron Fuller, CCIE 5851, is a huge F1 fan. So keep that in mind as you kind of go through this. Just a little bit of trivia there for you guys. Another feature of the Nexus that you're probably going to get quizzed on, because it is on the blueprint, is nonstop forwarding. And this usually is talked about in concert with stateful switchover. So what happens when you have a situation where you have two Nexus boxes, or we'll just say one Nexus box, and it's humming along like it's supposed to, and something happens, like you have to reload the control plane. Now, when this typically happens is when you do something like an in-service software upgrade, ISSU. If you have to bounce the control plane to bring it back up, or if you have to bring the secondary control plane online while you're bouncing the primary, the typical behavior of a routing protocol is once you lose the control plane, drop all of your neighbors. Something happened, the switch rebooted. We're not supposed to do that. So it's going to bring them back up. Well, in a small network or in a non-service provider network, that's not a problem. They'll reestablish themselves when the card comes back up. The problem is that control planes on Nexus boxes take forever and a day to reboot. Like, seriously, they take minutes. And you do not want your routing protocol to be down for minutes, especially if it's in a core device. So Cisco created nonstop forwarding with stateful switchovers to allow your routing protocols to not drop their neighbor relationships. So basically what happens with NSF and SSO when used in concert with SSO is that the data plane of the switch stays intact while the control plane is rebooting. And it does this through a process called graceful restart. And here's what it says. It's like I tell my kids. I'm like, all right, I'm going to go upstairs, and if you don't hear from me in 5 minutes, come to me. Okay. So they have a graceful restart timer. And if that timer elapses to the end before the control plane comes back online and tells it not to, it will tear down the neighbors and assume that the switch is dead and not just rebooting. You will use NSF if you're using stateful switchover, or if you're using, if you're configuring ISSU. This is what keeps your phone from ringing during upgrades. Because when the neighbors get torn down, the packets start getting discarded, everything goes into an active mode where it's trying to recalculate your routing tables, chaos, mass hysteria, dogs and cats living together, all of that kind of thing. So understand how nonstop forwarding interacts with all the various other mechanisms, and realize that the Nexus switch line, especially the 7K, was built to be bulletproof. You can do almost anything short of putting dynamite in that thing, and it will continue to forward packets. You can take control planes down. You can upgrade it while it's in production. You can actually upgrade the firmware on the cards while they're in production and just tell it not to make it live until you've failed traffic over. It's that kind of device. Speaking of redundancy protocols, one of the things that I wanted to talk about was Gateway Load Balancing Protocol, GLBP. Those of you who have worked in networking long enough are probably familiar with Cisco's HSRP, Hot Standby Routing Protocol. This is a first hop redundancy protocol that Cisco created to prevent issues where a gateway went offline. So what you do with HSRP, and I'm going to illustrate HSRP for you guys because it'll help you understand why GLBP is better. HSRP has two routers that come up, and one of them is in active mode, one of them is in standby mode, and they pick a MAC address and a fake IP, and they announce it to everything on the layer 2 segment as the forwarding gateway. And so what happens is when your machine comes up and it needs to get off the network, it ARPs for the gateway. It ARPs for its default gateway, and it gets the fake MAC address and fake IP address from HSRP and says, okay, I'm going to forward all my packets here. And when the packets hit that MAC address, the active router of the HSRP pair, by the way, HSRP can only run in twos, the HSRP pair forwards that traffic for you. Now, in the event that the active router goes dead or stops answering, the standby router waits for a period of time to elapse, and it's usually like a couple of seconds, and then it pops online and says, yay, I'm going to start forwarding packets for you. And that's HSRP in a nutshell. But it does have its drawbacks. It's Cisco proprietary only for one reason. That's if you look at VRRP, which is the Virtual Router Redundancy Protocol, VRRP is HSRP only standardized, and it has a couple of little quirks with it. There's no fake MAC address. It actually uses the MAC and IP address of the first router. The other thing is HSRP only runs in pairs, and it's active standby. It's not active-active. So if you want to use it for load balancing, you actually have to get really creative. So you have to create 2 HSRP instances. You have to set them to be active on one router and standby on the other, and then mirror it the other way. And then you have to send half of your traffic out one router and half of your traffic out the other. It's the same kind of crap we have to do with Spanning Tree to utilize all of our active links in the data center. And it's a pain in the butt. We don't want to do that. We want it to be automatic. We want it to be magical. And that's where GLBP comes into play. So GLBP was written by Cisco as a way to create not only redundancy, first hop redundancy, but to create true load balancing. So how does it do that? Well, GLBP, when you configure it on a group of routers, by the way, the max number of GLBP gateways is 4. GLBP designates one of those routers as the answerer, if you will. I forget the actual term for it. It's been forever since I've configured GLBP. But what happens is when a host on the subnet ARPs for the gateway, it knows that the address that it's supposed to be talking to is over here somewhere. Well, that gateway router, the active gateway, listens to the ARP request, looks at the routers that it has configured in its GLBP cluster, picks one of those MAC addresses and forwards it on to the host and says, this is your gateway for that IP. So essentially what you're doing is, if you're familiar with like DNS round robin, where you have a couple of DNS entries that you point all your servers to, and then you have a load balancer that basically picks one of the active servers and says, okay, you're going to use that one, you're going to use this one. It's the same thing at layer 2. And so you could do if you show ARP on 2 different hosts in GLBP, there's a very good possibility that for the same IP, they're going to have 2 completely different MAC addresses. But that's a good thing. And in the event that one of the routers in the GLBP cluster goes down and the devices that are using it are no longer able to reach it, whenever they try to contact it, it's going to fail. The gateway is going to intercept that, and it's going to reroute to one of the gateways that's back up. It's a better HSRP, especially for data centers. I would never use HSRP in a data center today. I would always use GLBP, even if you only have 2 routers, because GLBP has enough intelligence built in to actively decide that one of these links needs to be load balanced across. So even if it's just, eeny, meeny, miny, mo kind of thing. But with 4 routers in GLBP, you get real power to completely balance out your links. So understand how GLBP works as well, because Cisco loves GLBP, especially in the data center, and it's on the exam blueprint. All right, that's a lot of the talk about networking. I want to talk a little bit more now about storage, and I'm starting to wade into my territory where I'm not the best guy to be talking about this, but since Cisco considers storage part of Fabric, we want to talk a little bit about it, unless there were questions about some of the things we just talked about.
Yeah, there was a question about GLBP. Is it NXOS only?
No. You can run GLBP on standard iOS. In fact, GLBP is on the CCIE routing and switching blueprint. So, yes, for those of you who are using basic Cisco iOS devices to do some Cisco familiarization, you can configure a very basic GLBP forwarder setup on regular iOS, or if your data center interconnect switches are 3850s or 600s or something like that, you can configure GLBP. If you Google GLBP config, I think you can do it in 5 lines per switch. It's real easy. You configure GLBP, you give it an IP, you give it a priority, and it goes. Obviously you can tweak it beyond that, but it's real easy to set up. It's like OTV. When it works, it works. It's when it breaks that you really have to be worried.
And with it running on iOS, will it run on iOS 12 or does it need 15? Do you know versioning wise what version of iOS we need?
It'll run on 12.
Okay, 12 and 15.
Yes, it'll run on anything better than 12. Now, I don't know the exact version of 12. I know it'll run on 12.3. I had 12.3.15 loaded in my lab when I was studying for the CCIE, and I could run GLBP on it with no problem.
And one other question, is GLBP supported in a FabricPath topology, or I'm sorry, is Anycast HSRP preferred?
GLBP would be supported because it doesn't actually run in the FabricPath. It runs on your edge devices, which probably are not going to be part of your FabricPath. As to what you would prefer, that versus Anycast HSRP, I don't know the answer to that. I've never used Anycast HSRP. GLBP is what I've used in my deployments because it was a little bit easier, and I still have this phobia about using HSRP. I won't say it's a phobia, but I don't necessarily like HSRP. It's messier than I would like to make it work the way I want it to work.
Sounds good. I think that was all we had for that section.
Awesome. So let's talk a little bit about storage real quick. So one of the things I wanted to cover about Fibre Channel is the concept of zoning versus Cisco vSANs. And that's not VMware vSAN for those of you who are saying, hey, I recognize that acronym. No. This is a completely different one. So for those of you who have ever worked on a Fibre Channel box, you know what a zone is. A zone is creating basically an access list for Fibre Channel that permits a certain number of hosts to access a link on a Fibre Channel unit. Cisco came up with an idea of vSANs. These are basically VLANs for Fibre Channel, and they have some differences as I've illustrated here. So a vSAN, it's a separate namespace. It's self-contained, whereas in a zone you can have multiple colliding namespaces and it gets a little messy. vSANs can completely stop all broadcast, unicast, and multicast traffic. BUM, broadcast, unicast, actually it's unknown unicast, and multicast traffic. That's the chatty stuff in your network that ends up causing lots of problems if you can't control it. Zones don't stop that because broadcasts and unicasts can flood everywhere. The thing is, though, if your port is part of a vSAN, it's stuck in that vSAN. It can't get out of it. It's like an access port in a VLAN. Whereas if you zone a port, that port can have multiple zones that coincide with it. So you need to think about what you're doing with your vSANs versus your zones. Most people are going to zone Fibre Channel switches. I've never actually configured a vSAN, but I have zoned a few Fibre Channel switches in my lifetime. So know which one you need and which one would be appropriate for what. Remember how I told you that the design exam is all about figuring out which one you need to use and when you need to use it? That's the kind of question that they're going to ask you on the exam. When would you use a vSAN versus a zone? Well, if you want to make sure you don't have colliding namespaces, or if you want to stop multicast traffic, or if you want to make sure that the ports belong to a specific location and that only. Those are the kinds of things that you're going to see on the exam. I want to talk about Fibre Channel over Ethernet real quick. You're going to see some terminology about this on the exam. Fibre Channel over Ethernet was created by a bunch of different companies about 4 or 5 years ago. One of them, Nuova, was purchased essentially lock, stock, and barrel by Cisco. You may recognize some of the names from this that created it. Sonny Giandani, a bunch of other ones that are actually involved with the Cisco NCME project, Cisco Andiamo project that created the MDS fiber switch. They've built a few things that you've used. But Fibre Channel over Ethernet is encapsulation of Fibre Channel protocols inside of Ethernet frames. Now, why would that be important? Well, if you've ever built Fibre Channel networks, you know that they're completely and totally separated from everything else. They are essentially really expensive gigabit Ethernet networks that can never, ever, ever drop packets for any reason whatsoever. They're lossless Ethernet with different ether types. And so what happened was you have replicated cabling. Well, it doesn't make any sense from a converged networking standpoint if you have a fiber running to a server and a completely separate fiber running to a Fibre Channel card on that server. It's the same fiber, right? We know we have overhead and bandwidth. Why can't we figure out a way to converge both those protocols? And that's what Fibre Channel over Ethernet essentially does, is it creates a frame that is 10 gig Ethernet, but it contains Fibre Channel data. And it's forwarded over a lossless network, and it allows you to use one adapter in a server, a converged networking adapter, that contains a Fibre Channel and a 10 gig Ethernet stack. And when the frames arrive in the server, the network adapter does all the hard part of picking out the Fibre Channel frames and sending them where they need to go, and picking out the Ethernet frames and sending them where to go. In fact, the processor on the adapter is enough to handle a 10 gig interconnect link, but the Fibre Channel card actually has to shell out to the server's CPU to decode all of that. So it can be a little processor intensive. Fibre Channel over Ethernet is Cisco's baby. Not everybody believes Fibre Channel is going to last. Brocade, which is the big Fibre Channel competitor to Cisco's FCOE, will have you believe that faster Fibre Channel is better than FCOE and trumps the converged networking adapter argument. Other Cisco competitors like Arista will tell you that FCOE is a dumb idea. And time will tell who's right. But I'll tell you that Cisco is not going to let FCOE go into the dark by any stretch of the imagination. So you're going to need to know it. And if you're ever going to work on UCS, you're going to see Fibre Channel over Ethernet. It's a given. Let's go back a little bit of Fibre Channel real quick. Let's talk about the ports that you're going to see on Fibre Channel. So Fibre Channel has three basic ports. There's an in port, which is the end node of your Fibre Channel network. Think of that as a server. That's where the data, terminates essentially. Then there's the F port. The F port is a Fibre Channel port on a switch connected to an in port. So that's the access port, if you will, for the Fibre Channel data. Then you have an E port. An E port is a Fibre Channel port connected to another Fibre Channel port on a different switch. That's a trunk port or an ISL switch link. Funny enough, Cisco used to have a trunking terminology called ISL, inter-switch link, that was proprietary and was eventually phased out in favor of 802.1q standardized trunking. But when Fibre Channel over Ethernet started talking about connecting switches together, they reused the term ISL, inter-switch link, to talk about that. So it was really weird for me to excise ISL from my vocabulary once deprecated and then go over to Fibre Channel and all of a sudden see ISL being used again in the way I remember it being used, going, oh, wow, that's different. So you need to know where the in ports and the F ports exist in the terminology as a basic, because when you start monkeying around with those, that's when you run into other problems. And that's where you run into things like Fibre Channel's extensions, NPIV, which is in-port ID virtualization. You will see this. If you don't see it on the test, you'll see it in real life. So the way that it typically works on a Fibre Channel switch is that you have one in port, that server side. It connects to a worldwide principal name, WWPN, which is like a SAN identifier. It's almost like a MAC address for Fibre Channel. It's one-to-one. One in port has one worldwide principal name. And that works if the thing that's connected to it is one server that's talking to your storage unit. And 8 years ago, that was a really brilliant idea. It worked well. What's happened since then? Well, we had this thing called virtualization happen, where we don't just have one server talking to one Fibre Channel unit. We could have 50 servers talking to one Fibre Channel unit connected by one port. Oh, crap. That's going to break that one-to-one in port to WWPN extension. And that's where NPIV comes in. NPIV allows you to create an in port that has multiple WWPN associations. That means that the in port connected to an ESXi host can have an unlimited number of WWPNs associated to it, So that means that the VMs that are running on that server can have access to Fibre Channel storage zones that are not, they don't collide. Because, what if you run into a situation where the accounting server is virtualized right next to a web server? Well, if the accounting server can't block off the storage connection back to the payroll file from the web server and someone compromises the web server, they could very well read your payroll files without realizing what's going on. So the ability to have multiple WWPN extensions and to be able to zone them off is huge for making sure data is working the way that it's supposed to. NPIV is going to be important. I can almost guarantee you're going to see at least 2 or 3 questions on it on the test, especially on the implementation exam. You might also see a question about NPV, in-port virtualization. So here's what happens with in-port virtualization. It's a little bit different. They sound similar, and they use most of the same letters. You're going to think, oh, well, it's a little different. It's not quite the same. So in-port virtualization creates an NP port type. And what that does is it acts as an upstream proxy for imports. Now, you have to have NPIV support on the Fibre Channel switch. But what it allows you to do is it allows you to create a whole bunch of Fibre Channel NP ports without creating a whole bunch of domain IDs on your switches. That means it's a whole lot easier to scale it. Think of an NPV, in-port virtualization, as NPIV for switch ports instead of host ports. Scott Lowe has a really, really in-depth blog post article about this on his blog. If you Google NPIV versus NPV, it will come up in the first couple of hits. Read it top to bottom. Even though it's, I think, 4 years old at this point, it still gives you the basics. And that's the other thing you have to know about Fibre Channel. And if Jay Metz is listening to this, I love you, Jay, but you guys move slower than molasses in January. The things that Fibre Channel built 10 years ago are still just as valid as they were, just as valid today as they were back then. Because one of the things with Fibre Channel is everything has to be backwards compatible in order for it to all work the way that it's supposed to. So they take a lot of time to make sure that everything gets baked in the right way. And so when they create things like NPV and NPIV, what they created in Draft 1 is probably going to be pretty similar to what they have.
Hey, Tom, there was a few questions from a couple of slides ago. Back to just back to the basic FCOE. Is that something that's not routable, or is it is it a single hop only? You probably don't want to route this. Is that correct?
Oh, I just saw the hand grenade being lobbed into the chat room and then someone running away. So, as a rule, Fibre Channel is not multi-hop. It is because it's lossless. I think the max rule is you can go through 2 switches. So you can go from an F-port to an F-port, from an F-port to F-port to an E-port, back to an F-port, back to an N-port. You can go through a max of 2 switches before it, and it won't scale any further than that, which automatically limits the diameter of your Fibre Channel network. So that was the first thing that everybody asked when they started tunneling it through Ethernet was, hey, we can make it routable now because it's Ethernet. Yeah, not so much. You start introducing latency. You start having problems with creating instability. Remember, even though it's being tunneled through Ethernet, it's still a lossless network. I think the stat that I saw was in order for it to be rated correctly for Fibre Channel, it can't drop more than 1 frame in a million. Because a dropped storage frame is lost data. If we drop a network frame, oh well, we could just retransmit that. But you can't drop storage frames. So they've been working on multi-hop FCOE. It's a big deal. In fact, Jay Metz from Cisco, who I lovingly poke at every time Fibre Channel comes up, because he is the king of Fibre Channel over Ethernet, he's doing a lot of work. They've been trying to make it work right. It's not there yet. Multi-hop Fibre Channel over Ethernet is probably like it's the Moby Dick of storage and networking convergence. They keep hunting for it, but they can't quite find it. I may write a follow-up blog post about that as well, because it's something that people are going to want to know about. Multi-hop FCOE.
All right, and on that note too, there was a question about bonding E-ports for higher capacity. Is that something you can do? Can you bond those, or do you run a single E-port to a single E?
I believe you do a single E-port to a single E-port. I'm going to claim ignorance there because I've never configured a Fibre Channel switch in that way. I've never configured it to go more than one hop. Most of my stuff was just, it was local to one switch. But I think that you can't do port bonding, but I will get an answer for you on that.
Sounds good. And there was one last question about guest VMs, and let's see, how can the VM guest talk to the Fibre Channel over NPIV? There's no HBA to load drivers for. And if I think that one through, the guest VM doesn't necessarily know that it's talking through Fibre Channel. That's handled by the VMware kernel driver. If I'm
yes,
that'd be
right.
Handled by the hardware and the kernel itself.
Right. So it's just like any other storage protocol. The hypervisor itself handles the connection to the uplink SAN. So you go in and you tell it to attach to this Fibre Channel or to that iSCSI or to this JBOD, just a bunch of disks, wherever. And the guest VM is presented storage carved out of that pool. So to a Windows box, it looks like a network drive, or it looks like a local drive. To a Linux box, it looks like a mount point. Unless you want to do something where you want to attach it as a network-attached storage system. And I've done that before. I've presented an iSCSI LUN to an ESX box for local storage for VMs, and then I've gone into that VM and installed an iSCSI driver to attach back to that same SAN on a different LUN and use it as a network storage device. With Fibre Channel, you would need to have an HBA, but I think, and please don't quote me on this, I think there's a way to do a virtual HBA, a software HBA, but it's processor intensive. So I would suggest just doing it all with converged Ethernet adapters on your hypervisor and letting the hypervisor do all the hard work, and you just present it to the guest VMs as local storage.
The follow-up question to that was virtual HBA, how, question mark, how, question mark, how, question mark. Somebody's excited to know if you can do this and how with that.
Let me get back to you on that. And I could be totally wrong. In fact, I reserve the right to be completely wrong. But I would not be surprised if there wasn't a way to do it. But I'll have to look it up because I don't know for sure.
Sounds good.
All right. Actually, if you Google virtual HBA, there's a VMware blog post from 3 years ago about NPIV and how they're doing it. So VMware at least knows how to do it. You might want to look that up. Remember that even though it's VMware, that might come in handy later on down the road, even though this is a Cisco exam. Because as we all know, that exams don't test you on real life. They test you on what Cisco thinks real life looks like. And you'll know that that's true over and over again in your life when you do exams. So that's all I've got from a technical perspective. I just have a couple more slides to talk a little bit about the actual tests themselves. So if you have any questions about the stuff we just covered, now is the good time to be thinking about them. Let's talk a little bit about the exams themselves. Implementations, exams, that's what I covered. Here's a protocol, here's what it does, and here's how you put it in. That's an implementation exam in a nutshell. Little trivia bits about the pieces and parts. Design exams are different. If you've never taken a Cisco design exam in your life, you're in for a surprise, because there's very little to do with actual technology knowledge on the exam. Very little. What you do have is you have more knowledge of business requirements. And you will see the terminology business requirement in the design exam until you're ready to puke. They don't necessarily care about how you're using the technology, but they want you to know why you're using it. So, a sample question would be, you have a business requirement to connect 2 data centers over layer 2. Which of the following technologies would you use to do that? And the answers are probably going to be something like VPC, VSS, OTV, or FabricPath. And you're going to have to know, well, I want to connect 2 data centers at layer 2 over geographic distances. I don't want to use FabricPath because that's not what it's designed for. VPC, I am only going to use between 2 switches in the same data center, so that one's out. VSS doesn't run on this at all. So OTV is what I'm supposed to be using. OTV is the layer 2 geographic data center interconnect. And so that's what they're trying to do. They're trying to get you to think through the problem as a design engineer. So you're not actually going to go out and do CLI jockey stuff. You're going to be an architect. And so understand that. If you can think like that, if you can understand why those pieces need to fit, the design exam is probably the one that you're going to want to take because it gives you a 50,000-foot overview of the technologies. Now, if you're not so much keen on the design exams, but you love fixing broken things, that's where the troubleshooting exam comes into play. So for the troubleshooting exam, you really, really need to know the show command outputs. You need to know what a show command is going to give you. So if the question asks you something along the lines of display the routing table, you need to know that that's show IP route. But if the question says display the routing table for all, for all OSPF devices, you need to know that command is show IP route OSPF. You may see an exam question that has 4 show command outputs, or 4 show commands that are all like one word different. But if the question's asking you for a very specific output, you need to know which command delivers that output. And on past exams, I have seen them even put up the output of a command and say which of the following commands gave you that output. And you have to know which one it is. And you're going to want to familiarize yourself with that from a troubleshooting perspective. Also, do not rely on the question mark. And this is one of those Cisco test quirks. So if you're ever on the CLI of a switch and you don't know what a command does, you immediately hit the question mark. Because the question mark on a Cisco iOS device will tell you all the valid commands from the point you are in the command string. So if you type in show, hit space and question mark, it'll show you every show command you have. If you type in show space IP and hit question mark, it'll show you every command that starts with show IP, and it'll go down from there. It's really great so you know where you are and you know if the command you're using is right. But it's kind of a cheat insofar as that it'll tell you if you're using the right command because there's only so many commands that, that branch off of show IP, whatever. Now on the exam, most of the time they're not using real iOS. They're using simulations. So the question mark command is actually game-breaking there because if you question mark something that they didn't code for, obviously that can't be the right question, right? Or the right command you're supposed to use. So they disable the question mark if you're on a CLI. Don't rely on it. Know what the commands are. Know the basic commands. Understand what they're doing. And like I said, know the output because you may run into a situation where instead of them giving you access to an output, they may give you a telnet to a switch and tell you, find out why this is broken. And you have to go through and, like I said, with a license, situation, you may have to show license on the switch and see that, layer 2 basic license is enabled, and that's why FabricPath won't come up. Then that maybe the troubleshooting question is FabricPath won't come up. Why not? And you go down through the list. VPC isn't connected, or the license isn't right, or you're trying to connect to a non-Nexus switch, or something like that. Understand all of that, and that goes back to the implementation exam. You have to know the protocols, or you have to be able to see why they're broken. So that's what I've got. It's a lot of talk about protocols. It's a lot of talk about the pieces in a data center that interconnect things. As I said at the CCNA data center level, you're going to want to do some outside research on these. You're going to want to, pick out the pieces on the blueprint and go in and dig in a little deeper, and not just Cisco stuff either. I'll tell you that some of the greatest resources out there are the people who are looking at this and saying, okay, well, the document says that this is how I'm supposed to do it, but we all know documents lie. Here's how you actually do it. People like Ron Fuller, Denise Fishburne, Tony Burke, people that do this for a living and understand it. They're going to give you much better resources. They're going to, even if you have to learn it the Cisco way for the test, you're going to want to learn it their way in real life. So, don't be afraid to Google something. Don't be afraid to click on 3 or 4 Google links and make sure they all agree with each other. If everybody says you configure it this way and some other guy says, well, no, actually you need to do it this way, which is completely backwards, maybe he's onto something. It could be Bert being crazy, but, you want to understand the protocols top to bottom. If you understand the protocols, you'll be in good shape. One of my CCIA training providers, Narbit Kocharians, he was always really, when someone asked him a question in a class about why iOS did something, he would say, well, let's find out. iOS never lies to you. You put it through it may be a lie. It may not be the right command, but what you get out of it is always the truth, because iOS will never lie to you, and NXOS by extension in the data center.
Yeah, and on studying one last, I think one final question. Any update on VIRL availability that you know of, or anything to share?
Yes. So for those of you who did not listen to the CCNA data center that I talked about, Cisco has a new program out, Virtual Internet Routing Labs, or VIRL. It's actually being transitioned into the Cisco Modeling Labs CML product, although VIRL just sounds so awesome that you want to keep on using it. VIRL is a full virtual router suite. It is designed to crush things like GNS3 or Dynamips or Dynagen, for those of you who have been using that for some labbing and things like that on basic iOS. It's full virtualized routers. One of the things that I have found out was that NXOS will not be supported in the first generation of VIRL CML when it's released. I think it's on track to be released in the 3rd quarter of this year, and that's the 3rd calendar quarter. For those of you who don't know, Cisco's calendar year is up on July 31st, so they start a new year on August 1st. So be aware that anytime Cisco says Q1 of their year, that's August, September, and October. So I would bet on seeing an October-November timeframe, last part of October, first part of November, which is technically Q4, but they can surprise me. There's actually, I've shared an article from Paul Stewart, who runs a site called PacketU. We're talking about using Cisco's DevNet router in a box to do some modeling stuff if you're wanting to do it on regular iOS. So things like GLBP, you could do it there. I don't have an update on NXOS, whether or not it will be available in first ship VIRL. I would probably guess you're not going to see NXOS on VIRL and CML until at least 2015, which is not great for people who are studying for the exam today, but it's unfortunately about the best we can do for now. And a lot of it has to do with rewriting the emulation engines underneath to support NXOS. iOS XE was really easy to write for because iOS XE is essentially virtualized on hardware as it is now. iOS XE is monolithic iOS designed to run on a 2-processor core system, and iOS runs on 1 processor core, and they do other things with the other core. So they were able to virtualize it already, which is why they could just pick it up and drop it into CML VIRL.
Sounds good. Anything else? Are there any other questions around? I don't see anything hanging out yet on here or on Twitter. I'm in the VMware IRC room 2 on Freenode, and I don't see anything come up there. With that, is that everything that you have for us today, Tom?
It is, and as always, if you guys have any questions that come up after the exam or after the presentation, or if you find something that just doesn't make sense or I was outright wrong, which does happen, please don't hesitate to write a comment on my blog or hit me on Twitter. Again, I'm at Networking Nerd, or use the vBrownbag hashtag. Use that. I keep an eye on that as well. If I don't find your answer right away, I will get it for you. And I may end up writing a blog post about it. It may be so fascinating that I want to know more about it. But, the important thing is don't be afraid to ask questions, because everybody in the world that is a hot dog, top-notch network engineer at one point had a question, and they weren't afraid to ask it, and look where they got. So don't be afraid to ask.
Sounds good. We'll have this up and recorded. It's recorded. We'll have it up on professionalvmware.com. So check us out when we're done, or tell your friends if they want to watch it later if you learned something cool. Next week, the 23rd, we have vDocker with Chris Sears. Join us then at 7:30, same time, same place. Thank you, everybody. I am Anthony Hook, at Anthony R. Hook on Twitter. Add me, say hi. I also watch the vBrownbag hashtag on Twitter too, so drop us a line. Anything else to add?
I think we're good.
All right, cool. Thanks everybody for your time.
Thank you very much.
Have a good night.